Okay, let us start. In this week 8, in this session, we will discuss the week 8 questions. In this, we will discuss 5 questions, and these questions are related to the equation of motion for the multi-degree of freedom system. So, in this, we will solve different examples for the multi-degree of freedom system. Okay, so let us go to the first example. In the first example, you have given a like the derive the differential equation for the vibration of the system using x1 x2 and x3 as a generalized coordinate. So we have to develop a differential equation for each blocks, like says the 3 degree of freedoms are there, possible 3 degree of freedom x1 x2 x3. So we will have how many number of equation? We will have 3 number of differential equation. So we will solve it by one by one. So first, to solve this, we draw a free body diagram of the system, that how the forces are applied on the mass block. Okay, so for this, first we are drawing the free body diagram of the system. So for this, for the first block, you have, this is mx1, says like, if for the first block, like let us take x1 is greater than x2. This is assumption, not like certain things. So if that is your block, m block, if that move x1, so there will be a force which resisting the movement, which will be the k into x1. Okay, and now another force is applied through this spring 2k1. So that force will be 2k into the relative displacement, which will be the x1 minus x2. Okay, so this is the, these are the forces, and for this mass block, the force would be the mx1 double dot. So this way we will develop the differential equation for the different masses. So in this, we have, this one is the 2k x1 minus x2. So in this figure, this is like the sign is changed, so that will become as x2 minus x1. Now can you write the equation of motion for the second block, like forces in the second block? So for the second block, let us consider my x2 is greater than x3. So for second block, if you consider mass x2 is applied here, so what will be the my that force? That force would be the this one, because if this force is 2k x1 minus x2, so this force would be the 2k x1 minus x2. Whatever is the force is same, only the direction will be the different, and that force due to this spring would be the against this k into x2 minus x3. Okay, so for this you can see in this, so this is the force 2k x1 minus x2. These directions are different because if I take the negative outside, so that direction will become, if I will take this force, so this become x2 and this become as x1. Okay, and same for this k x2 minus x3, here I write at a k x3 minus x2. Same thing for the same forces will be calculated for the third block. For third block, let us do third block. X3 is there. If x3 is there, so what is the force is in this direction? K into x3. And what was the forces here? That was the k into x3 minus x2. So that would be the, in the opposite direction, k x3 minus x2. So this is my force I have written here. So have you understood like how I draw the free body diagram? Is there any doubt? Jyotiramai, is there any doubt? Do you have any doubt in the free body diagram? Okay, if no, then we are moving to write the equation of motion by one by one. So Let us first write the equation, write for the first block. So for the first block, that was the my free body diagram that I have drawn. And if I write the equation of motion for that, so that is the my inertial force mx1 double dash, and that is also in this opposite direction. So that my equation would be the mx1 kx1, and this is the opposite direction 2kx2. So that would be the in the negative direction. Okay, so if I will solve it further, rearrange the terms, so that will become as a mx1 double dot plus 3kx1 minus 2kx2 is equal to 0. Now for the write the second block, for the second block, like that free body diagram from the last slide, and if you write this equation mx double dot, this one and this one in the same direction, and this will be in the negative direction, this one. So these are the in the same direction, and that is in the opposite direction, so negative sign is there. So if you will rearrange the terms, you will get this equation. Now for the same, the for the third block, for the third block also, like all three forces are in the same direction, and this is also in the inertia will be in the opposite direction. So that would be the mx3 plus k x3 minus x2 plus k into x3. So that will be the this equation. So now after getting these three equations, we can write our equation in terms of matrix form. So if I summarize the equation in the matrix form, so that would be the mass matrix, that is my stiffness matrix. And if I will write like for the x1 x2 x3, these are the generalized coordinate. So in terms of the x1 x2 x3, this is the my equation of motion, differential equation of motion for this system. Okay, so now we are moving to the another question, in which question the spare of mass m is attached to the end of the cantilever beam. This mass is, this is a cantilever beam attached to this cantilever beam and fixed at the carriage of the mass 2m. That cantilever beam is also fixed to this 2m mass. So in the figure, the generalized coordinate of the systems are x1 for this carriage and x2 for this mass m. So respectively determine the equation of motion. First we have to determine the equation of motion, and then using the stiffness k value is equal to 35 kilonewton meter and mass is 35 kg, we have to determine the natural frequency and the mode shape matrix. Okay. So can you try to draw the free body diagram of the system? In the multi degree of freedom system, once you will be able to draw the free body diagram, you
हाँ.
can calculate easily the equation of motion of the system. Naresh, can you mute yourself? Naresh, please mute yourself. Okay. So in this question, we first draw the free body diagram of the system. So let us, this is my mass m, this is a cantilever, this has also some stiffness k1 says, and this carries mass 2m, and that is also attached to a spring, some sort of spring says. So these, like if I displace this carriers, like let us support this is a mass m and there is a spring here and there is a spring here, x1 is the deformation. So what will be the my equivalent, like let us say this is k1, this is k2. So what will be the my equivalent spring stiffness? That will be the k1 plus k2, because that will be in the parallel combination, because the displacement in both the springs would be the same. So I can write this as a k1 plus k2, that would be the 4k, and that is k. So if I have this kind of system, now we can write our differential equation. Is there any doubt in this, like how I simplify this problem into this? Anyone? Okay, if not, Then we are moving to further to the free body diagram. In this is what I have done in the last slide. Like this is stiffness is k, this is 4k. So now if that is a x2 degree of freedom, if I will apply x2, then what will be the forces there? That will be the k into x2 minus x1, like whatever the relative from for this one, like you cut it the section one by one. Now then I will cut it this section 2m, like the mass. So that is the inertia force, and the whatever force is there, that will be the reverse in this here. That is this is in that side. So that will be the here this one, and the 4kx1, this will also the resisting. You can make this case also if not understandable, like simple, like whatever I have written in last slide. Spring, mass, spring, and mass. So that is a 4k, that is 2m, and that is k, that is m. And now if you want to try, like what will be your forces? This is your x2, this is your x1. So for x1, if you draw like for a block, that is 2m, that will be the 4k into x1, and that will be the against this one 4k x1 minus x2. Okay, in this direction. And same for this block, this will be in this direction, that will be the, sorry, this will not 4k, this will k, and then this will be also k into x1 minus x2, and that is the only this stiffness would be there, and mx double dot x. So this way you can also solve this equation. Whatever way you want to solve, you can do it by yourself, there is no problem. Okay, so now after writing this equation, I will write the equation one by one. For the degree of freedom 1, for the degree of freedom 1 x1, my equation will be the 2m x1 plus 4k x1 minus this k, because this is in the opposite direction. So that would be the k x2 minus x1, and if I rearrange this term, that will come down to be 2m x1 double dot plus 5k x1 minus k x2. Same for the degree of freedom 2, that will be the, both are in the same direction. So that will be the summation mx2 double dot plus k x2 minus x1 is equal to 0. If I rearrange the terms, that is coming out to be this, these two equation. So if I will write these equation in terms of the, says in term of the matrix form, I can write this equation into the matrix form. These are the, that will be 2m and m x1 x2, and this is my stiffness matrix 5k minus k k k. Okay, so this is my the part A, solution of the part A. Now I need to solve the part B. So for the eigenvalue and eigenvector, I will determine the k minus lambda m determinant of this vector. So if I will take the this value 5k minus 2m lambda minus k minus lambda m. So can you give a try to find out what will be the value of my lambda? If stiffness is given to you 35 kilonewton per meter and mass is given to you 35 kilogram. So can you try to find out lambda? For after finding out the lambda, we can directly find out the eigenvalues. Like eigenvalues are the lambda, so we can find out the natural frequency. Then after finding out the natural frequency, we can find out the mode shapes. Okay, so I know one thing. If I will simplify, like I don't want, like if the I will put the k and m in this, so this will also sometime difficult. So I know what would be the my lambda. Lambda would be omega square, so that would be the k by m, and there is some coefficient also, let us say beta. So if I will put beta or lambda dash, let us say lambda dash. If I will put lambda is equal to lambda dash k by m, if I will put here lambda dash into k by m, so that m will be cancelled out and k will be coming out to outsider, that will become as a k square for the determinant, and then where lambda is equal to lambda dash k by m. So now this is a simplified equation. Now you can finding out easily the determinant of this equation. If I will like solve this further equation, like finding out the determinant, so this equation will become as a 5 minus 2 lambda dash 1 minus lambda dash minus 1. So if I rearrange the terms, 2 lambda dash square minus 7 lambda dash plus 4. So okay, your answer was the 12 and 5. That is your, what is your, this is lambda or the omega 1 final answer? Okay, so in this, no, sorry, okay, lambda 1 dash is 0.719 and lambda 2 is 2.78. So lambda 1 is coming out to 719 and lambda 2 is coming out to be 2780. So how you get the 5 and 12? You check your calculations. Like lambda is coming out around 719 and it is coming out 2780. Is there maybe any calculation mistake?
Sir, in the equation it is minus 35. No, sir, it is not minus 1.
Which one? This one?
Okay, sir. No, I got the clarity. Okay, sir, thank you.
That will be minus minus, that will be plus, and then again it will be minus.
Yes, sir, yes, sir.
Okay. So after calculating lambda 1 dash, lambda 2 dash, you can find out the omega 1 and omega 2. So now with these lambda 1 and lambda 2, can you give a try to finding out the mode shapes? If we go for a eigenvectors, for lambda 1 is equal to 0.719 lambda dash, you can directly put also lambda, but I have simplified this equation, so that will be the easy for me to calculating these things by manually. So if I will put lambda 1 dash is equal to 0.719, and if I, after solving this equation, I will write this equation as a first equation as a, because these two equations are the same, so that will be the first equation. X1 I use here initially this one second row, so that is a minus x1 plus 0.281 x21 is equal to 0, and I am normalizing the, my vector is the degree of freedom 2. So let us support x21 is the 1. So if this will the x21 is the 1, so my x11 will be the 0.281. Same thing for the, if I will put 0.789 instead of 0.79, I will put 2.78, and then I will try to find out the eigenvectors. So if I will put 2.78, simplifying this 0.56, 0.178, then take any one equation, any, let us say this one. So if this will be the x21, if you take any of the question, answer will comes out to be same. This one or this one, this one or this one, that will be the same. If I put x22 as a 1, so x12 is coming out to be 0.178. So this is the my mod shape vector. Is there any doubt in this question? Anyone? Okay, so now we are moving to the another question. This is a question which is like a single story building in which a slab is given and the four columns are attached to the slab, and these columns are clamped at the base like the fixed support. The slab has total mass m and it rigid in the plane and out of plane, like the deflection, like there is no deflection in the out in plane or out of plane. So each column is circular cross section, and its second moment of cross section in relation about any diametrical axis is noted, is given as a like is given for the column. This column says column D and column A, that is given 2I, and for column B and column C, that is I. With the degree of freedom ux, uy, and u theta at the center of the slab, and using the influence coefficient, first we have to formulate the mass and stiffness matrix in term of the for mass matrix in term of the M, and the lateral stiffness is the for the one column, the stiffness would be the k is 12 EI by h cube. So for this that would be the k, for this that would be the k, and for this 2I that would become as a 2k, and for this column also that would become as a 2k. So the for the column B, column D, and column A, that stiffness would be the 2k, and for column B and column C, that stiffness would be the k. So that after finding the mass and the stiffness matrix, we have to formulate the equations of motion for the ground motion in the x direction and the y direction and the in the db direction. Db direction is the this diagonally. Okay. So first we are going to formulate the stiffness matrix. Have you understood the question? So in the stiffness column, as we have discussed, like for the claim for column B and C, the stiffness is k, and for the column A and column D is 2k. We have discussed earlier. So for the stiffness, to get the stiffness matrix, first apply the unit displacement in that particular degree of freedom and finding out the forces, like the unit displacement at that particular degree of freedom, and the displacement at the other degree of freedom is 0, and we have to find out the forces at each degree of freedom. Okay, like says I have the 4 degree of freedom system, one, one, 2, 3, 4. If I apply the unit displacement says delta is equal to 1, so displacement in all three will be the 0, and I will find out the forces developed due to this unit displacement in all degree of freedom 1, 2, 3, 4. So this way I will calculate the my stiffness matrix. So for this I have 3 degree of freedom in this question. One is the ux, one is uy, and another is the u theta. Okay, so first I will apply the unit displacement in the x direction, which is ux. So if I apply ux is equal to 1, so other degree of freedom the displacement will be the 0. So if I apply the displacement is 0, so this is my free body diagram. So like this is the black one is the my original position of the slab, and if I apply the unit displacement in the x direction, so my slab will be moved this into the unit displacement 1. So there will be the force generated each degree of freedom. So we have 4 columns, so we have developed the forces in this, like in this displacement in this direction, the forces will be the in the opposite direction, the stiffening force. So the stiffness of the column B and C is k, so the force developed will be the F is equal to kx. So x is 1 unit, so force would be the k, whatever my stiffness is the force. So force developed due to the column B and C would be the k, and in the column A and D that would be the 2k. And in the forces, because the displacement in the other directions, so F is equal to k into x. So in the other direction says uy, says y or theta, that is 0, so my force developed in this direction also 0. Okay, so now I will find out what will be the y from here, like from this diagram. Can you find out what will be your kxx, kyx, and k theta x? Can you give it a try? Like you have given the kxx, kx is the force in the xx direction. So here the displacement is 1, so that force will be the kxx, and the force into the y direction kyx, and the in the k theta x. So can you tell me what will be the kxx? Apply the equilibrium equation. Summation of f of x is equal to 0. So summation of f of x is equal to 0. That means kxx minus these 2k minus these two forces is equal to 0. So what would be my kxx? That would become as a 6k. Okay. Same for kyx. So there is no force in the y direction. So my kyx would be the 0. And can you give a try for the k theta x? So for k theta x, this k theta x in the anti-clockwise direction. So these two forces are develop movement into clockwise direction, and these two forces are develop movement into the clockwise direction. So that would be the by this 2k into this distance, that is the b by 2 plus k into b by 2, and that develop into the clockwise direction. So that would be the 2k into b by 2 minus k into b by 2 is equal to 0. So these are cancel out each other. So that will become as a 0. So here kxx coming out to be 6k. Whatever I have done here, like 2k, 2k plus k in the that direction, opposite direction, kyx is 0, and the k theta x would be also 0. So whatever I have done here, same is done here. Like this is the movement in the another direction, and this movement due to this these forces due to the in the opposite direction. So both of them cancel out each other, and k theta x is equal to 0. Now apply the unit displacement in the y direction, uy. So if you apply unit displacement, uy is equal to 1, and the other displacement is ux, and u theta would be 0. So what will be my free body diagram? That is this way, like same the reverse kind of. So for this, same like for the kx and kyy, like for the kyy, that is the summation into fy is equal to 0. So kyy coming out to be, if I will plus all these things, this one, this one, this one, this one, that is become as a 6k. Okay. Now kxy summation of fx is equal to 0. So there is no force in that direction. So my kxy would be the 0. Now k theta y. For k theta y, if you take movement, like these two are in this direction of this k theta y, and these two are in the opposite direction. Okay. So this 2k and plus this 2k, 2k into b by 2 into 2, this is in this direction of the k theta y, and this is in the opposite direction, 2k into b by 2. So if you solve this, that is kb, that is 2kb, so that is kb plus k theta y is equal to 0. So k theta y coming out to be minus kb. Okay. Is there any doubt in this one? Any doubt? Okay. If not, then we are moving in the third degree of freedom system. Third degree, which is u theta. So if you apply u theta is equal to 1 and the other degree of freedom ux and uy is a 0, so that would be the this way, like my slab is rotated by theta is equal to 1, that is 1. So if that rotated 1 any slab, so I need to find out what will be the this displacement, like this corner b is displaced in this direction bx and by, force developed due to this. So if I will find out this displacement, this one, if this is theta is equal to 1, so what will be that length time this angle, so that what will be this length, that is diagonal. What is the diagonal of this, diagonal of this square, let us say this is b, this is b, so this will be the square root 2 of b. So the half diagonal center, that will divided by 2, so that will become as a b by root 2. So that diagonal movement is coming out to be b by root 2. If that is a b by root 2, says like this one, this is b by root 2. So if this angle is 45, this is 45, this is 45 angle, so that will be the b by root 2 cos 45 or cos 45 or sin 45. So sin 45 is also 1 by root 2, so that is also b by 2 b by 2 in both the directions. Okay, so now if this is a b by 2, so the force, like the for this column the stiffness is k, so the force resisting would be the kb into k into b by 2, for this k into b by 2, or for this the spring stiffness is 2k, so that will be 2k b by 2 and 2k b by 2. So now in the x and y direction you can calculate like in which direction that will be the spring forces, like says this is the moving in this direction, so there is resisting opposite force would be this one is the opposite, this is going upward, so that force would be the downward. Same for this, like this corner is going upward, so the force would be the downward, this is this one, this is going this way, so the force would be the opposite to this. Same for this corner, like this corner is moving this direction, so the force would be the in this opposite direction, which is this, that is going to downward, so the my force would be develop in the upward direction, that is this one. Same for this, like my force is this corner is going downward, so my force develop this, and this is going this one, this is going this one, this corner is going to this one, so that my force develop will be this. If you if you able to draw this diagram, finding out these forces in the free body diagram, then you can write the equation is generally simple, no, there is no problem in writing that is then the mathematical expression. First, like how to finding out this free body diagram and writing this, is that is the important part. Okay, so now if you understood this, now write the equation for the k theta x. So if you write the summation of the f of x is equal to 0, so k theta x, so k theta x would be the k theta x, this will be the kb by 2, and this is 2kb by 2, so that become as a 3kb by 2 in that direction, 3kb by 2, and this kb by 2 and this kb by 2 in the opposite direction, that is 3kb by 2 is equal to 0, so that will cancel out each other, so k theta x is coming out to be 0. Now ky theta, for the ky theta, if you take this one in the direction, like summation of fy is equal to 0, so that k theta y plus these two are in the upward direction, that is like 2kb by 2 by 2 become as a kb plus kb, this one, and this is in the downward direction, minus kb by 2 minus kb by 2 is equal to 0. These two will cancel out 1 kb, so your k theta y become as a minus kb. Okay, now for k theta you take the moment. Okay, so first I will erase this, so that Okay, so I have find out k theta x is equal to 0 and k theta y is minus ky kb. Now for the k theta you have to take the moment like this k theta into the anti-clockwise direction. Now determine that force develop the moment into the clockwise direction into this, that is also into the clockwise direction. These two forces also develop the moment into the clockwise direction. This one, this is also this one, this force also into the clockwise direction, this force also into the clockwise direction, this is also into the clockwise direction, so this is also into the clockwise direction. So all these forces develop the movement into the clockwise direction. So that would be the k theta theta is equal to this kb by 2, this 2 kb by 2 become as a 3 kb by 2. Like all these forces will multiply the lever arm, so that lever arm would be the b by 2, like the vertical or horizontal direct distance is the b by 2. So add those all these forces and multiply it with the b by 2. So that is coming out to be like we have four like kb by 2, this these are the four forces. So multiply the, this is the 4 kb by 2 and this is the lever arm b by 2. These are the four forces 2 kb by 2 and this is the force nine number of forces and there is the lever arm. So that is coming out to be 3 kb square. Okay, so this is my k theta theta. Okay, now I will summarize these forces like kxx kyy k theta x and all these line components I will summarize in the matrix form. So is there any doubt into the like this is my the stiffness matrix is become like for this that is the kxx kxy kx theta, same similarly this way kyx kyy ky theta, then k theta y k theta x k theta y and k theta theta. So this is our stiffness matrix. Now to formulate the mass matrix, for this mass matrix also we using simply like apply the acceleration unit acceleration at that particular degree of freedom and the acceleration is the other degree of freedom would be the 0. So for the ux1 in the x direction I apply unit acceleration in this direction, so the acceleration at the other points would be the 0, so that mx would be the this m and the other would be the 0 because the acceleration is 0. Same for the y direction I apply u theta, sorry, this will be the uy and that is u theta. So if I apply unit acceleration in this direction vertical direction, so that is same my is equal to m and other component would be the 0. Now if I will apply the u theta is equal to 1 and other component is 0, so like my bar is like the slab is rotating like this but the other component is 0, so that inertia about this point for the any slab we have to write it like this way it is writing and this is way it is rotating. So that will be the I naught is developing. So for any solid slab, rigid plate, if rotating, so inertia about this will be the mp square plus d square by 12. So here b and d both are the same. So if b is equal to b and d both are same, so that is become as a I naught is equal to mb square by 6. Okay, so this is my I naught. So here I can write out that the mass matrix as a mb square by 6. So after getting out the mass matrix and the stiffness matrix, the equation of motion to generate the equation of motion will be the very easy. Like for the equation of motion, my acceleration would be the u total acceleration would be the u double dot, that is the relative plus the ground acceleration. So in x direction ux total uy total u theta total would be the ux uy u theta is the relative whatever is the response in the structure and that is the external applied in the x direction the acceleration. So if I will write the equation for this like this is the total, like the acceleration is always taken as a total and the displacement is the relative. So if I will put u double dot as this one, this is replaced with this, these two. So one is remain here, and the another term, that term is goes to here, the negative. This is same for if you do for the y. So that is here it will become as a 1, and here become as a 0. So in y direction, the total acceleration is this, and if you replace the like that I have discussed earlier, that here it will become as a 1. Now the acceleration in the, if the external acceleration in this dB direction, this direction, if that is the unit says that this is one direction, so if you divide that into the, into that direction into x component and y component, so we have to look at it like this is ug direction. So what will be this component? That will be the u double dot g into square root 2, and u double dot divided by the square root 2. So that will replace by the in the x and y direction, that will be u double dot g by root 2, u double dot g by root 2, and same like replace that 1 by root 2 and 1 by root 2. So these are the influence vector. Influence vector. So for the in the dB direction, influence vector is the 1 by root 2, 1 by root 2, 0. For the y direction, that vector is the 0, 1, 0. And for x direction, that vector is the 0, 1, 0, 0. So this is the third question. So is there any doubt in this question? Any doubt, or should I move to further? Which one is the last part, like in the dB direction or the part B is whole? Which part? dB. Okay, like in the, like this is my slab. If I, my acceleration applied like the ground motion is, earthquake is coming in this direction way. So let us say this acceleration is coming out to be ug. So if I divided this component, like what would be the component in the x direction, what would be the component into the y direction? So this is the b, and this is b. Okay, so that is the says ug. So that you take the cos 45 term like the theta, so that become as a ug cos 45. So that is become ug by square root 2. Same for here, that is become also ug by square root 2. So my total acceleration would be the, whatever the acceleration in the structure response, ux double dot, uy double dot, and u theta, u theta double dot. This expression plus acceleration in this direction would be the ug by square root 2, ug by square root 2, and in the theta direction that is 0. Simple this term, whatever I have written. You know what is your equation, mu double dot ku is equal to 0. So this is your total acceleration. If you will put it as a u plus ug dot double dot. So if you will rearrange the terms, so that will become as a mu double dot plus ku is equal to minus mug double dot. So your ug vector is this, whatever the vector is this. Have you understood? Okay. So now we are moving to the another part, another question. In which question you have given a L shape beam, inverted L. So sometime to calculating the stiffness matrix, we are using the flexibility method. Flexibility, like if you have read your ug courses, two type of methods are there to finding out the matrix, like the solving the equation, that is the flexibility method or the stiffness method. So if you have degree of freedom is more than degree of freedom, more than like the higher the degree of freedom in the system, then we are using the flexibility method. And if you have lower degree of freedom, then we are using the stiffness method. So in this question, we have to find out the flexibility matrix, so that directly flexibility is converted to the inverse of the flexibility matrix, give us the stiffness matrix. So we will need to find out the flexibility matrix of this system. Degree of freedom given as a U1 and U2. Okay. So for this, in the stiffness matrix, I applied the unit displacement at that particular degree of freedom and other degree of freedom, that is 0, and calculating the forces. Now in this case, I will apply the unit load at that particular degree of freedom and calculating the displacement at the other degree of freedom. Okay, that gives me the flexibility. So for this, apply unit load in the u1 direction. Let us say this is u1 direction. If I apply a unit load in this direction, one direction, so that beam is going to this, like this way. Okay, so this is my deflected diagram if I will apply the one deflection at here. So the flexibility matrix, like I have to calculate the displacement at the u1 and u2. So whatever the displacement at this point will be the u1 same, and u2 I have to calculate what is the displacement at here. So if I apply the unit displacement at here, so what will be the displacement in the cantilever part? This is says length L. So for the cantilever, for the applied load P, my deflection will be the PL cube over 3I. P is 1, so my displacement will be the L cube over 3I. So whatever is the displacement is my flexibility F11. Okay. So for the U1, deflection at B is given as a PL cube over 3I, P is equal to 1. So flexibility is the inverse of the stiffness. So whatever the my flexibility, like flexibility is 1 by K, and K is stiffness is 3I by L cube, and if you will do the inverse, that is coming out to be L cube over 3I. So whatever your displacement due to the unit load, that is your flexibility. So now the flexibility matrix Fij represents the deflection in the jth direction due to the unit load applied in the ith direction. So F11 is the L cube over 3I. Now I need to determine the F21, means the this displacement due to this applied unit load. So this displacement, what will be the displacement? If I have a cantilever and there is a load, so there is a rotation also this point. So that rotation theta would be, let us say, this is not the load. Okay, that is load. If that is your, what will be the theta? This theta due to this load P1. So that theta multiply with this length will gives me the this displacement. Understood? Like the whatever the rotation at here, this point, if I multiply with this length, that gives me the displacement of this point. So if a cantilever, if I have P load applied, so that is my bending moment diagram PL. So what is the my displacement is area of this, that is the 1 by 2 PL square over 2EI. So my theta would be the P is 1 L square over 2EI. So this displacement become theta into L cube over 2EI. Okay, so the F21, due to unit load in the U1 direction, there is a rotation theta at point B, which I had discussed. So due to rotation, there is a displacement at delta C at this point, which is PL square over 2EI. So that displacement is the L cube L into theta. So that is PL cube over 2EI. So F21 is the L cube over 2EI. Now if I apply the unit load into U2 direction, which is this, right? If I apply the U2 in this, so this is my the deflected shape. So if I apply the U2 is this, so there is a what develop is there? There is a movement develop. Like says P is applied, so P into L is my movement develop at this point. So due to this movement, whatever deflection is there is my U1 into the U1 F12, and that displacement is due to this moment there is a rotation. So that rotation, what that rotation multiply with this length give me the displacement. That displacement plus displacement due to this P into L, that is PL cube over 3I. Okay. So due to unit load U2, there is a development of the moment at B. So if I have a moment in the cantilever at BM, so that is my bending moment diagram L. So displacement delta is become as a ml square by 2ei. So that moment is PL. So due to moment at B, the deflection of B is U1 in direction is mb L square over 2ei. So m will as a P into L cube become, and P is 1. So F12 is L cube over 2ei. Now for the F22, F22 would be the this one PL cube over 3i plus this displacement, the rotation. So what will the rotation? Rotation will be the ml over ei due to the moment. So if you will get the, like the displacement in u2 direction is the displacement due to the unit load at u2 delta c plus extra displacement due to rotation of b, like this rotation that will develop a extra displacement here, this one. So that due to unit load that is coming out to PL cube over 3i, whatever I have discussed earlier. And the extra displacement due to the rotation is the L into theta. So theta is ml over ei. Like if there is a moment here that develop the rotation is ml over ei. So if you will put the value of m, you will get L cube over ei. So your displacement is L cube over 3i plus L cube over ei is 4 by 3 L cube over 3i. So F22 is the 4L cube over 3I. So the flexibility matrix is this. Is there any doubt in this question? Any doubt? This is a simple, like you have done your UG courses also. But if still you have any doubt, you can ask me. Okay. If no doubt, then we are moving to the last question of this session. In this, if two identical uniform beams are arranged as shown in the isometric view in the figure, to support a piece of equipment of weighing 10 kilonewton, like this is my equipment says which weight is 10 kilonewton, the flexure rigidity and weight per meter of the beam are shown. Like to support this system, this machine we have make this kind of system. And for this system the weight of this system, let us like the for this beam, like in this question they tell that the mass distribution is that they have considered a lumped mass system, lumped distribution of the mass. So this system, the beam, the mass is here is the ml by 2, or at the edges that is ml square ml by 4. Like mass distribution of this, like this. For this one, ml by 2, and at the edge ml by 4, ml by 4. Like the distribution of mass in each beam to be lumped at the half mass is the center and the 1 by 4 of the each end. Like whatever I have done, half mass is distributed of this self weight is ml by 2 here and ml by 4 here. Compute the natural frequency and the mode shape of this system v1 and v2. Like they have given the hint also that the central deflection of the uniform beam with the central load plq by 48 ei. Have you understood the question? Is there any doubt in the understanding the question? Yes, what doubt? Can you tell me? Unmute yourself. Okay, you understood the question. Then let us move to the solution. So for formulation of the stiffness matrix, for developing stiffness we use the flexibility method here. So apply the unit load at degree of freedom 1. Like in this beam, that is the degree of freedom 1 and that is the degree of freedom 2. So if you apply the unit load to this, degree of freedom says this in the upper direction or in the downward. So that is deflected like this and that beam goes to this linearly, like I have shown in this diagram. So if you apply a unit load 1 here or P, so what is the deflection rate here? PL cube over 40 ATI. So whatever the P is 1, so your stiffness at that point F11 is become as a L cube over 40 ATI. And now displace if the due to this load we have to find out what is the displacement at here. So here that is the length is L or 3 meter like half. So that is the half. Like here it is the, let us say, delta. So the displacement at here will be the delta by 2 because that is linearly varying. So the unit displacement deflection at degree of freedom 1 is delta 1 is the L cube over 40 ATI. We have calculated it here. So now F11 become as a L cube over 40 ATI. So the deflection at degree of freedom is the deflection at degree of freedom 2 is linearly varying. Matlab, like this in this beam, the deflection is varying linearly because that is a hinge. So the deflection is the 1 by 2 of this, whatever getting is delta 1 1. So that is the L cube over 96 EA. Now apply the unit load at the degree of freedom 2. Like I will apply the unit load at this. So this is going to this, like due to this first it is also something also it deflected and that is also going to this. If I apply a unit load 1 here, then what is the reaction is here? 1 by 2, 1 by 2. Okay. So at here, F12, the deflection due to the 1 by 2. So that is a deflection due to P load is 40 ATI by L cube. If I will put P is equal to 1 by 2, that is become as a L cube over 96 EI. Deflection at this point. And at this point, I have to calculate like the deflection due to the unit load is PL cube over 48 EI plus the extra deflection is this. This much is the extra deflection will be the linearly varying. Like here it is the L cube, like delta, so that will be the delta into 1 by 2. So that is the L cube over 96 EI. If you will sum up it, you will find the answer. So like let me erase this. So like I will apply a unit load into this. So that deflection is the L cube over 48 EI and there is extra deflection in this beam also, that is due to the 1 by 2, that is this one L cube over 96 EI. So the deflection at degree of freedom 2 is calculating, first we calculating the F12 deflection due to load at degree of freedom 1. So that is load at degree of freedom 1 is 1 by 2. So F12 is L cube over 96 EI at degree of freedom 1. Now the deflection at degree of freedom 1. Wait 1 minute. I have done some error mistake. deflection at 1 initially, that is the 1, that would be 1. Okay, so the loaded degree of freedom 1 is 1 by 2, so that is F is equal to L cube by 96 CI. Now the deflection at degree of freedom 2 is coming out to be F22 is deflection at degree of freedom due to the unit load 1 3 beam this beam plus 1 by 2 whatever I have done here, 1 by 2 into delta. So that is L cube over 48 is the deflection into the that particular beam plus the deflection due to the other 04 beam. So that will, if you will sum up it, that will become as the 5 by 192 L cube over EI. So that flexibility matrix is become is this. Any doubt in this at any point? Can you, like, if you have any doubt, please ask. If there is any doubt, anyone, you can ask here. So the after finding out the flexibility matrix, we can finding out the stiffness matrix is equal to 1 upon F, that is 192 EI by 16, that is 5 minus 2 minus 2 4. So I have given the EI value as a 2400 kilonewton meter square or 2400 into 10 raised to power 3 Newton meter square, and the length of the beams are 6 meter. So if I will put the value of the EI and L, so that is coming out to be K is equal to 40,000 3 5 into minus 2 4. So there will be the L cube also. So if you will put it this here, 192 into 2400 10 raised to power 3 is 16 into 6 power 3. Yeah, that is correct. Like here, that will be the L cube. Okay. So this is the K. Now the formulation of the mass matrix, same way, like mass distribution is at the ends, it is given in the question, at the ends it is distributed ml by 4 and at the center that is ml by 2. So as the mass distribution with the degree of freedom 1, this is our degree of freedom 1 and this is our degree of freedom 2. So at 1, that will be the mass of this ml by 4 and mass at the center ml by 2. So that is become as a 3 ml by 4. Now at this degree of freedom, that mass is ml by 2 plus extra mass of this weighing machine 10 kilonewton. So the at degree of freedom 2, the mass is ml by 2. So that is become as a m11 as a 20.25 and m22 is the ml by 2 plus w is the 10 kilonewton mass is distribution. So the mass matrix is become as a 20.2500 1032.86 kilogram. Now calculate the eigenvalue and eigenvector. So for this, we have calculate k minus lambda m. So this is my the equation, like I have put the k minus lambda m, and if I will solve this kind of equation I get. And if you solve this polynomial equation, 2-degree polynomial, I will get the lambda 1 and the lambda 2. So that lambda 1 is coming out to be 411.79 and lambda 2 is the 33,026.44. So the model frequencies are the omega 1 is the square root of this and that is the square root of this. So omega 1 is the 20.3 and omega 2 is the 181.73. So now using this omega 1 and omega 2, you can calculate the eigenvectors. So therefore the lambda 1 is equal to 411.79. I will put the take the place of the lambda, I will put this 411.79. So I will choose any one of any equation. So first I have solved this and I have take the first row. So from here, if I will consider phi 2 1 as a 1, 511 is coming out to be 0.4056. For lambda 2, 33,026.44. K minus lambda is coming out to be this one. And if I repeat the same procedure like rearranging the terms, and I have considered the first row, and for I have put this one, this equation as a 1, so my 512 is coming out to be 125. So this is my model mode shapes like 0.40561 125 1. Okay, so this is the, I'm concluding here the session, a week session of this session, this live session for week 8. If you have any question, you can ask me here, or else you can ask through the discussion forum. I will discuss these questions into the next live session. Okay, anyone have any question, or should I stop this?